Good morning, grade 8. Today we are going to start chapter 5, thermal energy and heat. Move to lesson 1, temperature, thermal energy and heat. What's meant by temperature? Temperature, a measure of the average kinetic energy. Temperature, a measure of the average kinetic energy of the particles in an object, or how hot or cold an object is. Because we mentioned before, any matter, any object made of particles, maybe solid, maybe liquid, maybe gas, the particles have kinetic energy. So the particles move. Yes? The movement of particles or the kinetic energy of particles, this is what I mean by temperature. Measure the average kinetic energy of the particles in an object. Okay, as an object heats up, its particles move faster. As a result, both average kinetic energy of the particle and the temperature increase. We have a scale to measure temperature. I need to measure the temperature. We have three common scales: Fahrenheit scale, Celsius scale, and the Kelvin scale. Okay? Number 1, Fahrenheit scale, most common temperature scale used in US. The boiling point in Fahrenheit scale is 212 Fahrenheit degrees. Don't forget, the Fahrenheit scale tells me about boiling point, which equal 212 degrees, Fahrenheit degrees. Yes? The boiling point of water, 212 Fahrenheit degrees, the boiling point of water. What about freezing point? Freezing point of water is 32 Fahrenheit degrees. 32. This is freezing point. Don't forget, the freezing point of water, 32 Fahrenheit degrees. What about Celsius scale? Celsius scale, temperature scale used by most of the world and the Arab world. The boiling point, all of you know, the boiling point of water is 100 Celsius degrees. The boiling point of water is 100 Celsius degrees. Look at the two scales together, Fahrenheit and Celsius. The Fahrenheit boiling point 212 against 100 Celsius degrees. Yes, and the freezing point used by Fahrenheit scale 32 Fahrenheit and 0. The freezing point, sure, 0 Celsius degrees. So Celsius degrees against 32. Yes, and Fahrenheit, 0 freezing point, 32 freezing point for Fahrenheit. Yes, the two scales together. What about the third scale, Kelvin scale? This scale used by scientists, and the unit is K. Yes, Kelvin, K. Units on Kelvin are the same size as degrees on Celsius. 1 degree, move with 1, 1, 1, like Celsius. 0, 1, 2, 3 until reach 100. Also, Kelvin, move by 1. Yes? So, Kelvin scale divides into kelvins, K, a temperature change of 1K, change by 1K. Yes? Not like Fahrenheit. Not like Fahrenheit. Yes? Because the difference between 32 and 212 equal, I mean not move with 1 Fahrenheit. Not move with 1 Fahrenheit. 1 degree not equal 1 Fahrenheit, like Celsius, 1 degree equal 1 Celsius, or Kelvin, 1 Kelvin equal 1 degree. Yes? Kelvin and Celsius completely different than Fahrenheit. Okay? So Kelvin scale divided into Kelvin scale, a temperature change of 1K as the same temperature change in 1 Celsius. So the freezing point in Kelvin scale 273. The freezing point in Fahrenheit was 32. The Fahrenheit, the freezing point in Celsius scale 0 Celsius degrees, The freezing point in Kelvin scale 273 K. Look at boiling, 300. So the difference is 100. Exactly like Celsius. The difference between freezing point and boiling point is 100 degrees. Yes? Also the difference between freezing point and boiling point also 100 degrees. But the beginning, the freezing point is 273 Kelvin and boiling point 373 Kelvin. The difference is 100, like the difference between freezing point and boiling point in using Celsius degrees, Celsius scale. What about 0? 0K. 0 by the E. 0K ده equal الابسوليوت 0. 0K اللي هو الابسوليوت 0. الابسوليوت 0 اللي هو 0K ده بسميه او named as lowest temperature particles, which means the particles have no kinetic energy at absolute 0. Absolute 0, which equal 0K equal negative 273 Celsius degree. To reach 0, we mentioned the freezing point 273. Where is the 0? The 0 called the absolute 0. When we reach 0, absolute 0K, which means absolute 0, this is happen at negative 273 Celsius degrees. So 0 Kelvin equal negative 273 Celsius degrees. Okay? So wide range. Kelvin, wide range from 373 boiling point and the freezing point 273 and 0 absolute 0. Absolute 0 or 0 Kelvin, which equal negative 273 Celsius degrees. Okay, at this degrees, no motion, no kinetic energy for particles. Okay, negative 273 Celsius degrees, which equal 7 Kelvin. Okay, move to the thermal energy. So we did temperature. Thermal energy is the total energy of all particles. Temperature tells me about kinetic energy only, average kinetic energy. But thermal energy tells me the total energy of all the particles in an object. Thermal energy is the total energy of all the particles in an object. This is thermal energy. Total energy of all the particles in an object. Factors affecting thermal energy. Factor affecting thermal energy. Thermal energy, total energy of all particles. What are factors affecting? Number of particles. Because the object or matter made of particles. So number of particles in an object affect thermal energy. Number 2, temperature of the object. The average kinetic energy of the object. This is the temperature, is a factor affecting the thermal energy. And the arrangement of particles. If the particles arranged in a regular way, like solid, completely different than liquid, completely different than gas. So the arrangement of objects' particles affects the thermal energy. We will study first 2 factors of number with temperature. What about number? The more particles means the number increase, yes? The more particles an object has at a given temperature, more thermal energy. But as the number increases, the thermal energy increases. Sure. So 1 liter pot of tea, 1 liter means 1000 cubic centimeters. At 75 Celsius degrees had more thermal energy than 0.2. 0.2 means 200 cubic centimeters. So 1000 at temperature 70, the temperature is fixed, 75 has more thermal energy than 0.2. Sure, miss. Because the both contains more T particles. Okay. The higher the temperature an object has, the more thermal energy. Also, a liter, 1 liter, were at 90 Celsius degrees, and 1 liter with 50 Celsius degree, so the 1 liter with 90 Celsius degree has thermal energy than 1 liter at 50 degrees. Okay? So higher temperature, more thermal energy. Example, 1 liter. I have 2 containers, 1 liter and 1 liter pots of tea, have different temperature. Yes, one with 50 and one with 90. The pot with higher temperature has more thermal energy, as I told you. Last one, the third scientific term, heat. We did temperature, average kinetic energy of an object. We did thermal energy, the total energy of a particle of an object. And last one, heat, transfer of thermal energy from warmer object to cooler object. This is heat. It's the transfer of thermal energy from a warmer object to a cooler object. Why? Due to temperature difference. Due to temperature difference. The warmer object will cool when the temperature released, and the cool one will be warmer, will gain energy. So the warmer object will cool down, and the cooler object will warm up until they are the same temperature. When this happens, the heat stops transferring. We use unit to measure the heat energy of an object, joule, like kinetic energy, like electrical energy, like potential energy. The unit used joule. Joule units used to measure heat and thermal energy. Yes, we did thermal energy and heat, first lesson of this chapter, temperature, thermal energy.